Question 1. What is data science? List the differences between supervised and unsupervised learning. Answer. Data science is a blend of various tools, algorithms, and machine learning principles with the goal to discover hidden patterns from the raw data. How is this different from what statisticians have been doing for years? The answer lies in the difference between explaining and predicting. Statisticians work a posteriori, explaining the results and designing a plan. Data scientists use historical data to make predictions.
Question 2. What is selection bias? Answer. Selection bias is a kind of error that occurs when the researcher decides what has to be studied. It is associated with research where the selection of participants is not random. Therefore, some conclusions of the study may not be accurate. The types of selection bias include sampling bias. It is a systematic error due to a non-random sample of a population causing some members of the population to be less likely to be included than others, resulting in a biased sample. Time interval. A trial may be terminated early at an extreme value, often for ethical reasons, but the extreme value is likely to be reached by the variable with the largest variance, even if all variables have a similar mean. Data. When specific subsets of data are chosen to support a conclusion or rejection of bad data on arbitrary grounds, instead of according to previously stated or generally agreed criteria. Attrition. Attrition bias is a kind of selection bias caused by attrition, loss of participants, discounting trial subjects/tests that did not run to completion.
Question 3. What is bias-variance tradeoff? Answer. Bias is an error introduced in the model due to the oversimplification of the algorithm used, does not fit the data properly. It can lead to underfitting. Low bias machine learning algorithms, decision trees, KNN and SVM. High bias machine learning algorithms, linear regression, logistic regression. Variance is error introduced in the model due to a too complex algorithm. It performs very well in the training set but poorly in the test set. It can lead to high sensitivity and overfitting. Possible high variance, polynomial regression. Normally, as you increase the complexity of your model, you will see a reduction in error due to lower bias in the model. However, this only happens until a particular point. As you continue to make your model more complex, you end up overfitting your model and hence your model will start suffering from high variance. Bias-variance trade-off. The goal of any supervised machine learning algorithm is to have low bias and low variance to achieve good prediction performance. 1. The k-nearest neighbor algorithm has low bias and high variance, but the trade-off can be changed by increasing the value of k, which increases the number of neighbors that contribute to the prediction and in turn increases the bias of the model. 2. The support vector machine algorithm has low bias and high variance, but the trade-off can be changed by increasing the C parameter that influences the number of violations of the margin allowed in the training data, which increases the bias but decreases the variance. 3. The decision tree has low bias and high variance. You can decrease the depth of the tree or use fewer attributes. 4. The linear regression has low variance and high bias. You can increase the number of features or use another regression that better fits the data. There is no escaping the relationship between bias and variance in machine learning. Increasing the bias will decrease the variance. Increasing the variance will decrease bias.